All right, without further ado, let's get into actual discussion or the lecture. In this one, I'm actually going to do all of chapter one. It's very vocabulary heavy. Most of this is already written out for you. There's just a couple of fill in the blanks. I'll add in some important information that I feel that is important for you and for the homework itself. In the past, this has been very useful. But again, if you ever need more examples or help, again, please reach out. I don't mind helping you as much as I possibly can on all your assignments. In the assignments, the grades are really kind of up to you, how you want to do it. If you want an A, go for the 100. If you're satisfied with the 70, you have that ability. But again, you have about 15 attempts per problem because you have 3 attempts or 5 attempts, sorry, and then within each attempt, each question has 3 attempts. So you can use the suggested guided practice that's with it, and it'll kind of guide you through a different example, and then you can use that to help you answer the question if you're still confused. All right, but in chapter one, we're going to be talking about the nature of probability and statistics. And in 1.1, we first start talking about the difference between descriptive and inferential statistics. So to learn this subject, we need to speak the same language. So we first spend time learning the definitions of terms we use, and that's what this main chapter is. So the very first question here is, what is statistics? So statistics is the science. So a couple of things to highlight here. It is a science of conducting studies to collect, organize, summarize, analyze, and draw conclusions from data. Why do we use statistics? Well, statistical studies are performed within most professions. To understand the result, you will need to know the vocabulary, the symbols that we use, the concepts that we use, and procedures that we use. So to understand this, you need to understand all of statistics, be able to analyze statistics as well. And statistics is really just about in every career field. You yourself might not be asked to use it, but using it gives you an edge on company growth and decay and things like that. And it could show you up on a good little meeting with your boss if you know what you're talking about. All right, you may conduct research in your field. You need to be able to design experiments, select samples, collect data, organize, analyze, and summarize the data, make reliable predictions, and communicate the results of the study. As I just said a while ago, you want to use, understand, and analyze statistics presented by governmental and commercial entities in order to make informed decisions for your company or for yourself. All right, in this first objective, we're going to demonstrate the knowledge of our statistical terms. All right, so a variable is a characteristic or attribute that can assume different values, measurements, or observation. Customer names, amount of daily sales, favorite television programs are all variables. You also have hair color, and hair color could simply just be like blonde, brown, black, gray, etc. All kinds of different examples there. Or you could have a number situation where it's maybe just the number of credit hours you're taking. So maybe you're taking 5 right now, maybe you're taking 22, etc. Whatever amount that you could be doing. So it could be words or it could be a number as well. So when these values are determined by chance, the variables are called random variables. So if you're not just pinpointing someone with blonde hair, you're just pinpointing somebody and they happen to have blonde hair, it becomes a random variable. So results of the roll of a die or a lottery winner are examples of random variables. Dice that are randomly rolled, lottery numbers picked are all random, so the winner will be random as well. So value measurements or observations that variables can assume are called data. Measurements include such as the height of customers, time between eruptions of geysers, circumference of a tree trunk, weight of a package, A1C levels, all different type of examples here to represent measurements. Observations include things like hair color, number of shirts on a rack, number of behavioral incidents within a specific amount of time, all observational things that you've observed. If we keep going a little bit further here, a collection of these data points or data collected or data values forms a data set. All right, so each single value in the data set is called a data value or a datum. This is a data as in plural. Um, it is the actual thing that can be assumed. So after we analyze this data, it is the things that we can assume about the data. Maybe there's 20% of people that are blonde-headed, or maybe 12% of students are taking 3 credit hours or less, things like that. So things that we can look at the data and then assume things about it. Within this part here, you have a population, which is going to be all of your subjects of interest or being studied. Subjects may be humans, animals, business entities, products, etc. The size of the population usually makes gathering data from every single difficult due to expense or time. So then what we do, we take that population and we take a sample of it, which is a group of some subjects selected from the population. So, for instance, if I'm looking at a specific group, this whole thing will be the population. But let's say there's 100,000 people in this population. I can't survey 100,000 people. So, what I'll do is I'll take a sample of maybe 1,000 people. And after those thousands of people, they'll tell me what 100,000 people might be represented as. Right? So in objective two, we're going to talk about differentiating between the two branches of statistics. And that is statistics is divided into two main areas, determining the way the data is used. We have first descriptive statistics. This is basically meaning you are describing something. Right? Descriptive statistics describes a situation. So descriptive statistics consist of collection, organization, and summarization. And presentation of data. No conclusions are drawn. The data are merely described. So what descriptive statistics basically states, you have 22 blonde students. That is descriptive. This is a fact about it. When you're like, well, overall, 12% of students are blonde. This is not descriptive. This is an estimate of how many students are blonde. So describing statistics is, again, factual. It's telling you exactly what happened in this study. When you start throwing in a certain percentage or you start throwing in, I think this is going to happen, that is an opinion, that is not factual, right? So, your personal activity monitor may collect data about the number of steps taken in a day, the number of active minutes per day, the type of exercises completed. When results of several days or several different people are considered, the charts displaying the data and the averages of the variables are descriptive statistics. So, again, we're taking data from people, and that's what we're plotting. So, that would be things that actually happen, not things that we're trying to concur. That's very important to understand that, because in the next half of statistics is what we call inferential statistics. And this part is basically when you are inferring something, meaning you're taking the descriptive statistics, the data, and you're basically thinking, well, because that's what happened in this small group, this is what I think is going to happen in the entire population. So inferential statistics consist of generalizing from samples to population. So we take something that happened in a sample and we assume what's going to happen in a population. So this is where we're now making estimates, performing hypothesis testing, determining relationships among variables, and making predictions. So descriptive, factual, things that actually happen. Inferential, we're now taking that and inferring what we think is going to happen overall. So know the difference between the two. All right, so thus inferential statistics involves using probability to make predictions and draw conclusions. Hypothesis testing is a decision-making process used to evaluate claims about a population using randomly selected sample data. Inferential statistics is what we do a lot of. It's a lot of stuff of the information that you see. We give you descriptive statistics, and then we go, based off this, this is what we're trending towards. And it can kind of be a little biased depending on the situation. So descriptive cannot be biased because it's factual, things that actually happened. Where inferential could be biased depending on how you're pulling your data. And we'll talk a little bit more about that later on. So looking in this example here, it says owners of comic book shops are concerned that sales of comic books are declining. A study revealed that women currently account for 53% of comic readers from a graphic policy and Facebook. 3 years ago, women accounted for 40% of readers. So over time, depiction of women in comics has changed. Further study is needed to evaluate whether the perception of women is affected by the rise in strong, confident female comic characters depicted as heroes in movies. Also, currently, according to WSC professor Joe Salzman, fewer than 30% of comic characters and writers are female. And this again is from Firmaso J on September 11th of 2014, The Rise of Women Comic Buyer on OZ.com. It has been predicted that comic book publishers will focus on comics that lure the female comic book reader. So then let's take all of that information, and the whole point of statistics is to take the information and analyze it and pull things from it. So one of the main things that you'll need to be able to do is answer these type of questions. What are the variables under study? And there's a few things that you can choose from. We are looking at the comic book sales. We are looking at the genders that are purchasing it. And we are looking at the gender of comic book characters. So again, you're looking at the sales of women, but overall, you got to have to analyze women and men. You're looking at the genders of the purchasers itself, and then why are the genders picking it? Is it because of the gender of comics characters? So again, that last one there is gender of comic book characters. All right, the next thing you need to be able to do is what data has been collected. What is the descriptive data here? And you can see that maybe we have the sales by genders. That was the data that was given to us. So sales by gender. We have total sales in general. A relationship, or sorry, a readership by gender. So we know exactly how many are reading comic books. So a readership by gender. We also are collecting female characters by strength and confidence. So female characters. So we're analyzing that and seeing, hey, this is what we saw in female characters. I think it was like 30%. Is that the rise there? Is that's what's causing more females to read comics? Um, Comic writers by gender. They gave us that data on how many actually writers are of female origin. And then the change in percentage over time for genders. So gender change over time. I believe it started with we saw it's at 53%. It was 40, so they gave us that. So that's all the data that was collected. That's not something that we're assuming. This is things that were in the article that we pulled from it. So have descriptive, inferential, or both type of statisticals been used? Yes, both. We saw how many actually purchased it, and then we are now assuming it's rising because there's more female comic book characters. So the more we have comic book characters, the more rise in female readers. So there's inferential, the actual data. We see that 53% of more females are buying books versus 40. So that's inferential, that's actual data versus now we're inferring, well, we think it's because of this. So both are being used. The next question is, what is the population under study? A lot of people will go, well, they'll go the entire population, but that's not true. What we're specifically looking at in this study here is only comic book readers. We don't know overall the entire population of the world. We're just looking at just people that read comic books. And then out of those comic book readers, we are looking at their gender. So again, our population study is all comic book readers, and our sample comes from this single comic book shop. So there might be millions of comic book readers, but our sample will be only coming from a comic book shop owner. This is a owner that is seeing the uptick in that area. And then there could be other characteristics. There could just be more females that are moving into that area. There could be, I don't know, all kinds of different things. There could be a decrease in the male population. There could have been something that happened. There could be a war. Things like that could affect the statistics as well. And those are what we call other unknown variables that we don't know about. But we're just, again, inferring on what we're seeing with the data. All right, another quick question there. It just says from the, let me get to that point for you. It says from the information given, comment on the relationship between the variables. So now it's just asking you be able to infer something from it. I actually would probably, in my sense, I would probably infer that the more female representation, the more female readers. I see it as maybe females will see themselves in it and then have a new role model or something like that. So that could be something that I infer. You could infer something different. You might infer that, well, males don't read as much. So maybe the male population is going down and the females actually staying the same, but statistically speaking, maybe it's rising. Whatever your reason is for it. All right, so that's your 1-1. And on your homework, it is just chapter 1. So it's over all of this stuff. The rest of the chapters are broken down by section. So that's kind of why I'm making this lecture all of chapter